I'm Harshada Javeri. I'm a senior machine learning automation engineer at Epson Fiery. I was actually working with AI agents and on doing some POCs at my organization, and I got very excited when Hawk and Prasad has shared me how I can implement that in inside my enterprise level workflows, and there I got connected with them, and it's been an awesome journey. This demo will walk through on how like CI/CD failures are analyzed and detected and resolved using this QAOps orchestrator. And we will show you how the logs can be analyzed, and we can check the actionable insights from the portal.okahu. And yeah, and the core tech is involved is Gemini, LLM, and Okahu observability layer. So let's get started. So the problem statement which would we would be like to solve is like the CI/CD failures which are coming from the pipe CI/CD process that are majorly get unnoticed, and the logs get reviewed and the engineer get notified, and then it is debug and retry. This loop happens, and in this process there's 30 to 60% of QA time lost, spent on manual triage per cycle. And we can see the high recovery time, or the MTTR, mean time to recovery, from the defect is logged to the defect is fixed. That time is basically lost. So we involve this agentic AI orchestrator or ops agents, so they can basically remediate the low and medium priority issues, and the high priority issues based on the confidence score can be basically remediate to the human in the loop. So this is overall like problem which we are solving. We face very silent failures, noisy logs, and repeated mistakes which happens while debugging. And where the Okahu comes in picture is for AI agents observability. Basically, we need like where the agent is failing, where how this architecture is we can improve on, so there we can check. So here is the solution which we bring is specialized agent roles. So to have the multi-agent pipeline of orchestrator, we have a test diagnostic agent which parses the logs, extracts the failed test, and classifies the error pattern. Then we have the root cause analyzer agent. It does all the LLM analysis and has the queries memory bank, and it generates a hypothesis based on with the confidence scores. And then we have the action planner agent, which generates the remediation steps, creates Jira tickets, uh, uh, and then it passes on the steps to the execution agents. And the execution agent basically executes the actions automatically, and it creates and update the Jira tickets. So the main core of this all four agent is the orchestrator that is controlling the execution order, and it is basically making the system more modular, deterministic, and scalable. And this is the multi-agent flow. Basically, we have all our Jenkins CI logs, GitHub Actions log, or any sample log input into our event ingestion layer. And it basically parses through all these agents, and they take the necessary actions of creating the remediation plan and Jira ticket as required based on the confidence score. So let's know how this intelligent multi-agent architecture works in the backend. So basically, whenever like the CI/CD logs are running, or the tests are giving us the failed results, they are passed into the log filter, and the key logs are analyzed based on the key error signals, which extracts only the key error signals and passes to the orchestrator. The orchestrator will then triggers the automated workflow of all these four agents. It will call the multi-agent pipeline step by step. So the diagnose agent will identify that what has failed. The analyze agent will determine that the root cause of the issue. And the planning agent basically will decides the next action based on the confidence score, whether to pass it to the execution agent or to fix that. And the execution agent performs the actions like ticket creation. And here, while throughout this whole pipeline is working, Okahu observability layer basically gives us the full traces, root cause, and suggested fix as well. So let's take an example of this real example of two failures. Here I have this error due to test user authentication, and the other error is a test create user. These two are distinct error types, and manually debugging this will take approximately 20 to 40 minutes for an engineer. So if we parse this logs to our ops pipeline, we will check like how we can basically remediate this and within minutes. So Okahu trace-driven intelligence will give us the full execution context of how all the agents are invoked, the traces end-to-end based on the trace IDs. Then it will also like have the memory basically, which can be used for the next cycle of uh, next cycle of agent pipeline or agent calls. So let me just guide you through the Okahu portal where I have set up this multi-agent QAOps orchestrator, and I have selected the last 1 month traces, and you can see like 62 traces have been invoked for all these agents, and we can check the traces basically here. So this is the latest run basically, and it is giving me this agent invocation, the QAOps pipeline, the test diagnostic agent, the test root cause analyzer agent, and the inference also, and the input and output for these agents, which prompt we have given. And based on that, the action planner agent as well, we can see the input, output, and responses, and for the execution agent as well. So main thing basically you can check here as in the architecture of this overall multi-agent orchestrator, we have the QAOps pipeline and all these four agents, and whichever LLM models we are using, that also can be shown here. And on the GitHub side, I have like basic architecture repository structure as in like agents, tools, utility, tests, and the main orchestrator file, which is the entry point of the multi-agent pipeline. The predict.py has the script to label all these failures, and the observability for telemetry setup. So let me just guide you through the one live example of, suppose now I have connected the Okahu MCP to my workflow. So here I have asked the MCP or like GitHub Copilot to get me the trace results from Okahu MCP for this particular trace ID. So it has executed and ran the get trace spans method, and it is giving me the trace summary for this, and it is giving me all the span hierarchy, and I can check the input to all these agents, what input has been passed, like two errors we have got for the test login and test checkout failed. So it is able to basically analyze those errors, and it all these agent invocations and the output also based on that, it has shown us the traces. So the action planner agent, you can see like it has created the priority as high and confidence is 0.85, which is greater than 0.8. So it will create the Jira ticket. So I have given another prompt to the MCP Atlassian with the project Scrum board, which we have configured on Jira. So I have given the prompt to fetch the latest trace ID from .monocol folder using Okahu MCP and retrieve the full trace details. So, and generate the remediation plan and create Jira ticket. So it has basically created this Scrum Jira ticket for this latest log which is being faced. So here the manual efforts of creating the Jira tickets is being reduced. You can see this on this project, the Scrum 13 got created, and we have the description, failure step, and fail test added automated. And here failure this issue can be basically assigned to the concerned engineer to take the necessary actions. So this is how this overall multi-agent pipeline will work. And it will basically solve the problem of mean time to recovery in this whole process, that total downtime due to all the incidents divided by number of incidents. And where the Okahu MCP and memory comes into picture is, it will recognize the patterns and it will store all these logs, so it can be used for the further invocations. And we have like before Okahu usage and after Okahu, you can see like we have 30 seconds of, like, basically it is giving me in 30 seconds the uh, fixing so of all these issues. So we get all the minute of downtime saved for the engineering team stuck in the log files. So yeah, that's it. If you have any questions, let me know.
Yeah, awesome, Ashada. One thing, if you can show like the code that you instrument, maybe you can walk through like the two line that we put in your Python file.
Yeah.
So for people on the call, there's this solution here is something we partner up with Hashada at Fiery, and there's a mix of different products in here. So the QAOps is basically Hashada inventions, and Okahu is the piece that we instrument inside that QAOps agent. Um, there's also a use of different MCP tools in here, like the Jira MCP would kick off and create a Jira ticket.
Yeah.
Okahu MCP is being used to do a local investigation, like what Hashara just showed there on the chat windows. We talk with the traces, like we question what's inside the trace and we get information from the trace, and use that information to to troubleshoot the agent. So to instrument this, Hashida, if you can go to the Python file where you, was it in the orchestrator or the action planner? I forgot.
Orchestrator, we have all these agents, and we have like Okahu integration and Okahu integration.py. So there are only two lines basically that we are invoking. I have created the integrated orchestrator here.
Where is the line that say like the setup Monaco telemetry? Can you search the code really quick for that?
Yeah.
It's setup Monaco telemetry setup underscore Monaco.
Yeah, I think. Yeah, in observability.
So there's an observability module that you kind of create, and then you pull that into different components, and you call that init telemetry. So
Yeah. So
traditionally, if you write open telemetry, you have to like throw code everywhere, randomly in different places. For Okahu, so Monaco is an open source that we sponsor. It's a two-line of code. You can see the line 13 and line 48.
what?
And of course, like we do coexist with other technologies. So you can see they're live, 14 open telemetry as well, but it's optional. Definitely we have a lot of people who, are pretty strong supporter of open hotel. So coexist, so we can pretty much just simplify the use of tracing with the two lines of code there. Okay.
Yeah. And like I think I can quickly show like the traces as well if you have time.
Mhm.
So
Yeah.
anyone.
So for people on the call, feel free to unmute yourself, ask any question if you
Yeah.
want.
So I can basically check the use latest trace from .monocle to generate the code fix using GitHub Copilot and update the corresponding Jira ticket with the proposed solution. We can ask the Okahu MCP as well to detect the root cause and generate the remediation plan and create the Jira ticket, basically. via this prompt. So this we can ingest into the GitHub Copilot and having this MCPs configured.